video, their learning target, there are actually three. The first one is I can recognize and represent proportional relationships. 2, I can decide if two quantities are proportional. And 3, I can identify the constant of proportionality. Our essential questions, how do you set up a proportion? And number 2, how do rates and unit rates relate to proportions? We have 4 math practice standards, 1, 3, 4, and 7. Key vocabulary, there are only 2 new vocabulary words we're going to add, and the first is the constant of proportionality, and that is essentially the constant unit rate, and unit rates are just like what we've been finding. Proportion, and that's an equality of 2 ratios. We're going to start out by looking at an example. And the example says, at Cocoa Bean Chocolate Factory, 2 pounds of their fudge sells for $1. How much can we buy with $5? You can see that I have underlined our rate, or our ratio, I guess I should say. 2 pounds of their fudge for $1. There are actually 3 ways, if you remember, that you can write ratios. We can write 2 pounds to $1 using the word 2. We can write a ratio like a fraction. Or the third way, we could use a colon. That's $1. Now what we want to do to help us actually solve our problem, we want to use equivalent ratios. So we're going to use the one that is set up like our fraction. And we know that that is 2 pounds for $1. Now, one of those learning targets, or actually I think it was one of the essential questions, wanted to know how to actually set up a proportion. And what we have to do is we have to make sure that our numerator in one fraction matches what the units are for the second fraction. So when we want to know how much can we buy for $5, we're looking for how many pounds. So that would be X number of pounds for, and then our money, which is also our denominator here, would be that way. Now we want to think, what am I doing from here to here? Multiplying times 5. So I will do the same thing from here to here. We will multiply times 5. Once we do that, we will see that our 2 ratios, 2 pounds for $1, is equal to 2 times 5, which will give us 10 pounds for $5. Now, if we want to look at these and see if they are actually proportionate or set up as an equal proportions, we can look at their cross products. We can multiply the 2 and the 5 and the 1 and the 10. 2 times 5 should equal 1 times 10 if they are proportionate. And 10 does equal 10. So therefore, this would be considered proportionate. Our next example is actually going to come in 2 parts. We want to look at this table here and we want to know, do the numbers in the table show a proportional relationship? And if we look here, we can see, again, what's happening to the 1 to get to 3, 3 to 9, 4 to 12, and so on. Down here, I've done the actual math. We've seen that 1 times 3 is 3, 3 times 3 is 9, 4 times 3 is 12, and then the last one says that 7 times 3 is equal to 18, but we know that is not true. So if you look over here, I wrote a star here and I've written one up here. The row with the books, with 7 books for $18 is not proportional to the other rows. The table does not show a proportional relationship. Because again, if each one of these is multiplied by 3, this should also be multiplied by 3, and it is not. All right, our second part of this example, we are going to actually look at this as a graph. And I'm going to have to zoom in on the graph itself. We are going to ask ourselves, is the graph proportional? And we're going to look at these as ordered pairs, looking at the number of books and the price. The number of books being our x coordinate, the price being our y coordinate. Our first ordered pair is 1, 3. When I graph 1, 3, then I have 3, 9. Go over 3 and up to 9. 4, 12. And then lastly, 7, 18. Now I have to take a ruler because I want to draw this line, connect it, and you can see that as I start to draw the line, if I continued along my ruler, you would find that this dot does not fall on the line. It is actually a little bit off. And you can see that my line doesn't actually stay straight like a line. It does go through the origin, but it will not stay a straight line in the end. Okay, there are a couple of things that we want to look at for this graph. Then it will help us answer whether or not it is proportionate. First thing we want to do is we want to look to see, does the number line stay, or does the line stay straight? And no, it did not. Does it go through the origin? Yes, if we had extended it, it would go through the origin. If a line stays straight and goes through the origin, it is proportional. Since this one does not, it is not considered a proportion, which is what we also saw when we looked at the table. All right, we can look at one more thing before we zoom out. Putting a box around this point here, that is actually our unit rate. And our unit rate, if we're looking at a graph, shows us that wherever x is equal to 1, wherever the dot is, that's going to be our unit rate. Now our unit rate, we had 1 to 3, essentially. So for every one book, it cost us $3. All right, let's zoom out a little bit, and I'm going to write down a couple of things that I need you to also write down, some things that we have noticed. First thing is that the unit rate when x equals 1, what is y? That's your unit rate. The second thing is that our unit rate is our constant of proportionality. And then the third thing, a graph will show a proportion if it forms a straight line that goes through the origin. If not, it is not a proportion.